All right, in today's lesson here, we're going to take a look at the surface area of composite shapes. And we've got a bunch of composite shapes. In this case here, even some basic ones. This is not a composite shape, but we're going to be taking a look at some composite shapes as well as we go through these, finding the surface area of them. So let's take a look at the first example. So for our first example here, we have a square-based pyramid. For calculating the surface area of this object here, what you need to do is go ahead and try to envision painting this object and the faces that are needed to be painted if you were given this object. So right away you can see here, okay, if I'm going to be painting this object here, I've got like this triangle face here I like to calculate the area of. So keep in mind, volume is a concept of cubic measurements. So like if this were volume, this would be inches cubed. This is surface area, so it's going to be inches squared. So I'm going to label this area of my side. And the side shape here is a triangle, and you guys know the area of a triangle is base times height divided by 2. My base in this case is 16. My height is given to me in this question, so if you take a look, they actually gave me the slant height. This is called the slant height of your pyramid in this case, and the height of the pyramid goes from sort of the peak here down at 90 degrees. That would be the height of the pyramid. So they didn't give us that. We didn't need it. I did need that 17, which was given to us, and divided by 2. So this represents the area of one side of the face of the triangle. You can see here, because we do have a square-based pyramid, I know that this face of the triangle here, this face of the pyramid, I should say, and the back and the other side there are all going to be the same. So I can go ahead and multiply this by 4 all the way across. Again, multiply this by 4. And putting that together, I can get the area, which is 544 inches squared. So that represents the area of all 4 sides of this shape here. We want to go ahead and calculate the area of the bottom, because again, we're looking for our total surface area. The bottom is a square, that's 16 times 16. That's going to give us 256 inches squared. So you can see here with this basic shape here, the total area is obviously just the sum of the 544 plus the 256, which gives us 800 inches squared. So you can see here in this example, calculating the surface area is a combination of the area of a square, and then you've got ourselves 4 triangles, all the exact same triangle. Adding them up, we have our total area or surface area. Let's take a look at another slight variation on this problem. So let's take a look at a very similar question. However, in this example here, what they've given us is they've gone ahead and given us the height of the pyramid instead. So we do not have the slant height. I do not have the slant height here. So let's go ahead and see how we would do that. First of all, I'm going to go ahead and take care of the area of the bottom, which is the easiest step here. The area of the bottom is just going to be your 17.5 times your 32. And that's going to give you 560 square feet. Now we want to go ahead and I want to calculate the area of one of these faces of the triangle. Now, if you'll take a look here, to calculate the area of one of these faces of the triangle, I need the slant height. Well, the slant height is going to be connected to our height, which was given to us. So I'm going to have to go ahead and use Pythagorean theorem here. You see this creates a right angle triangle. If you want to take a look a little bit closer, I've got my right angle triangle. I know this is 24. This is given to me in the question. I know the distance from here to here is 32. And this is the exact midpoint. So I know that's going to be half of that, in which case that's going to give us 16. So I'm going to go ahead and I'm going to calculate my slant height using Pythagorean theorem. Doing so, we get s squared is 24 squared plus 16 squared, in which case we get s squared is 832. And taking the square root here, I get approximately 28.84. And that represents the slant height of this side of the triangle. Now you'll notice I've got my slant height here, and I know that the slant height is approximately, let's just make a note here, it's approximately 28.84. So I'm kind of back in this situation here, with the exception that I don't have a square. So we're going to have to talk about that in a bit, but I do have my slant height. So I can go ahead and calculate the area now of the sides of some of these triangles. You'll take a look here. If I go to calculate the area of the side of this triangle, it's going to be your base which I know is 17.5. The height, which I've just found, is approximately 28.84, and I can divide that by 2. Now, the exception here that we're running into is we only have 2 sides the same this time, because this side will be the same as the back triangle here. However, we will not have the same thing happening with these front sides. So we're going to have to calculate a new slant height for those ones. So I can only multiply this by 2, whereas before I could multiply by 4 because we had a square-based pyramid. So calculating this out, we end up getting here 50.47 square feet. And again, that represents the area of 2 of the faces of our triangle. I want to go ahead and calculate the area of this here. So once again, I'm going to have to go ahead and use Pythagorean theorem. And you're kind of calculating the slant height this way now. So looking at that triangle, you can kind of draw this off to the side of your page. I've got the triangle on this side. This is going to be my 24. It's still a 90-degree angle. Now this time what we're doing is I'm cutting this length in half. The length from here to here will be exactly half this length. So if you take 17.5 and divide that by 2, you end up getting, you get 8.75. And again, I want to find S once again. So this will end up being my S squared is your 24 squared plus 8.75 squared. If you go ahead and take the square root and solve, we end up getting, I get 25.55 feet for my slant height for this question here. So you'll take a note here. Now when I go to calculate the area of the side of this shape, so now the other 2 sides of this, it's going to be your base, which in this case is 32, times your height, which we calculated is 25.55. I'm going to divide that by 2, and again, there's 2 sides, a front and a back on this. I'm going to have to double those numbers. And doing so, I get the area of this side of the triangle is approximately 817.45 square feet. And just a quick adjustment here. This number was just a decimal place off. It should have read 504.7 square feet. I just wanted to make note of that because I saw when I calculated this area of this face, I got 817, and this was 50.47, which is obviously wrong. It was so much smaller than the other one, so I knew something was off, and it was just a decimal place off. So now I've got the area of the sides, 817 and 504. If you add those together, that'll be the area all the way around. I also have right here the area of the square at the bottom. So let's total this up together and get a final answer. So summing this up, we end up getting here for this question 1,882.15 square feet for your total area here. So again, notice here with this question, I had to go ahead and do the slant height twice because this was not a square-based pyramid. I had to actually calculate it twice using Pythagorean theorem this way and then this way to get 2 different answers to calculate the area of each of the different faces, right? This face in the front was the same as the face at the back, hence the times 2. And this face on the left is the same as this face on the right, hence the times 2. And then we've got the area of the bottom shape calculated here, added up, and we're done. All right, let's take a look at another. So for the next shape here, we want to go ahead and calculate the surface area of the following shape. So you'll notice here right away, let's take a care. I'm going to label this as like 2 separate shapes here, shape 1, shape 2. I'm going to go ahead and take a look at this composite shape. I'm going to start off with shape 2, it's just a little bit easier. Right away, you'll notice I've got myself a cube. So the area of the sides of this shape, I can label this as 6 times 6 is the area of one of the sides. And you'll notice this consists of, normally the cube consists of 6 sides. The top side is being covered by our square-based pyramid here. So I'm going to have to multiply this only by 5, and that'll give us 180 meters squared. Now I'm going to go ahead and calculate the area of shape 1. So if I'm looking to calculate the surface area of shape 1, you'll notice once again, I do not have the slant height here. I'm going to have to go ahead and apply Pythagorean theorem to get that slant height. So I know the height is 6. I know the leg of this triangle will be 3. Again, that's going to be half the length from here to here. That's going to give you 3. And I'm going to go ahead and calculate for my slant height. So this is going to be 6 squared plus 3 squared. You're going to end up getting that S is equal to the root of 45, which is approximately 6.71. So now when I go to calculate the area of one of the faces of this shape here, it's the area of the base, which is 6, the height, which is 6.71 divided by 2. And now you'll see here, because we do have a square base pyramid this time, I can multiply this just directly by 4. And I end up getting that the surface area around this object is 80.52 meters squared. So when I total this up and add up the total area, I've got the 180 square meters from the cube at the bottom plus the 80.52 meters, giving me 260.52 square meters for the surface area of this object. Let's take a look at another. So this question here, we have two hemispheres connecting the top and bottom of a cylinder. We're going to go ahead and calculate the surface area of this one. First of all, if you recall, the surface area for a cylinder is 4 pi r squared. And if you take two hemispheres, put them together, you have a full sphere here. So that means that the surface area is just going to be 4 pi times 2 squared. And I end up getting here 16 pi for the surface area of the sphere. Now if you take a look here, I have myself a cylinder. Now the surface area for a full cylinder would be 2 pi r squared plus 2 pi r h. But as you know here, this the 2 pi r squared represents the area of the top and bottom of the cylinder. Those, like, pi r squared is the area of a circle. There's two of them, 1, 2. That's where the 2 comes from. Both of those are being covered by the hemispheres individually. So I'm going to kick those completely out of my equation. So the surface area formula that I'm interested in is really just like the label of this shape here. So this is going to be 2 pi times the radius is 2 and the height is 5. And that's going to give us 20 pi. So my total surface area is just the sum of both of these. So you'll notice here I got 20 pi and 16 pi. It's going to be 36 pi. And if you go ahead and get this to a decimal place, 36 pi equals approximately 113.10 square feet. And that would be representing the surface area of this object. Let's take a look at another. So for the next question here, we want to go ahead and take a look at the surface area of this object here. And you can see here, a little bit of work has to be done. I'm going to label this 1, I'll label this 2. Let's start off with 2 here. If you take a look at 2, again, you have yourself a cube. So I know the surface area of this cube, one of the face of the cube is 5 times 5. That would be 25 is one face of the cube. If I multiply that by 6, that's actually going to give us the surface area of the entire cube, which is good, but you'll notice I've got this space here that is overlap, and I want to omit that. I want to kick that out of my equation because that's not part of your surface area. You're not painting that. So I'm going to go ahead and subtract off the area of that circle. This circle right here has a diameter of 4. So therefore, pi times 2 squared will represent the area of that circle. So by subtracting off the circle, you have the surface. I've counted the surface area of the top, the entire thing. And then by subtracting off that circle, you're left with the distance all the way around this object, sort of trying to draw around it by subtracting. So now I've calculated this. So if I do this calculation here, we end up getting approximately 137.43 square inches as the surface area of shape 1. If I do shape 2 here, again, back to our cylinder argument, I'm just taking a look at the top of the cylinder, so I'm just going to put pi r squared. I'm not going to put 2 pi r squared because, again, this circle is being covered between the cube and the cylinder, so it's not part of my surface area. Then I'm going to go ahead and add 2 pi rh. So I can put all those variables into my equation. Again, my radius here is 2, and the height of the cylinder is 4. And I end up getting I get 62.83 square inches for the surface area of the cylinder, and therefore we need only to add these two together. So summing these two together here, I can get my total surface area, which is approximately 200.26 square inches. And now I've gone ahead and found the surface area of this object here. All right, let's take a look at another. In the next question here, we have ourselves, again, looking to calculate the composite surface area of this shape here. Just got to break this up. I'm going to label this 1 and 2. We can kind of take a look at these shapes individually. If you look at shape 1, I'm going to go ahead and calculate the area of the front and back. So I'll let F be the area of the front and back. So the front of this shape is going to be this dimension here. That's going to be 8 times 2. So we're going to go 8 times 2, and there's 2 sides to that, so I'll double that. Then we have the area of the left and right of shape 1. So if you take a look at the right-hand side of shape 1, that's going to be 5 times 2, and there's going to be 2 sides to that, so I'll double that. And continuing up here, I have the area of the top of this shape. And the top of this shape, as you can see here, it's going to be 8 times 5. And we have to go ahead and calculate that. And then lastly, I should actually calculate the area of this shape here. I can kind of include that with my shape 1, let's say. But if I go ahead and do that, if you take a look here, it's just a rectangle. And the length from here to here is just going to be a result of taking the 12 and subtracting the 8, in which case you'll get that this is a 4. And we already know that this length here given to us here is a 5. So I know area of, I'm going to actually label this, let's label this like piece 3. And I'm going to go to piece 3 here. I'll call that area, and that's going to be 5 times 4. So I've got my 20, and this is going to be 32. This is going to be 20. This is going to be 40 for these units here. And if I go ahead and move on to shape 2 here, again, you go through the same notation. I'll call it area of the front and back for shape 2. The front here is going to be 4 times 12. So I'm going to go 4 times 12, and there's a front and back to that, so I'll double it. Then I have the area of the left and right. This side here, this is going to be 5 times 4 for the area of the left and right. And again, there's 2 sides there, so I'll double that. And then lastly, I have area of the bottom here. And the area of the bottom is going to be 12 times 5. So going ahead here, I end up getting 96. That'll be 40, and that'll be 60. So go ahead here and add up your 32, 20, 40, 20, 96, 40, and 60. And I have my total surface area comes out to be 308 square feet. And we have our total surface area for the shape. All right, that concludes today's lesson on calculating the surface area of composite shapes. Thank you.